I'm going to look at one additional example with you for finding the inverse of a function. And I specifically wanted to look at this type of problem because students tend to have a little bit more difficulty finding the inverse when you have a fraction. All right, so remember that because the fraction is the part of this that ends up being the most difficult to deal with, that is the part that we're going to work on first. All right, so I'm going to write my function down. I'm going to go ahead and make it y is equal to instead of f of x. And then remember that your first step is to switch the x and the y. So I'm going to go ahead and do that. So instead of y is equal to, it's going to be x is equal to. And instead of 2x plus 1, I'm going to have 2y plus 1. And the denominator is going to change from x minus 1 to y minus 1. Now again, because the fraction is the part that is the most intimidating for us to work with, we're going to deal with that first. So I'm going to eliminate that fraction by multiplying both sides of the problem by the denominator. So the denominator is y minus 1. So I'm going to multiply both sides times y minus 1. So on the right-hand side, the y minus 1s are going to cancel out, which just leaves me the top part, the 2y plus 1. On the left side, I'm going to go ahead and distribute as I write this down. So I'm going to multiply that x times that y. And then I'm going to multiply that x times that negative 1, which will be a negative x. Okay, so we now have the fraction taken care of. The next thing that I want to work on is getting all of the terms that have a y value, because remember I'm trying to solve for y. So everything that has a y on one side of the problem and everything that doesn't have a y on the other side. So it doesn't really matter what order we move things in. I'm going to start with this 2y and I'm going to subtract it off of both sides of the expression. All right, so when I do that, I'm going to come up here. When I do that, I'm going to have xy minus 2y minus x. I'm just putting those three terms on the same line. And then on the right-hand side, I just have a 1. All right, and again, remember what we're doing. We're trying to get the y's on one side and everything that doesn't have a y on the other. So the next thing I need to do is add the x to both sides of the expression. All right, so that is going to give me xy minus 2y is equal to 1 plus x. Okay, so that's kind of the second step. The first step is to get rid of the fraction. The second step is to separate things so that if it has a y, it's on one side. If it doesn't have a y, it's on the other. The third thing I want to do is look at the left-hand side, and I want to factor a y out of both of those terms. I'm going to leave the right-hand side as it is, but on the left-hand side, I'm going to factor the y out. So when I take a y out of xy, that just leaves me an x. When I take a y out of negative 2y, that leaves me a negative 2. All right, and solving for y, I'm going to then divide both sides by x minus 2. All right, and so we're going to end up with this y. I'm going to turn back into my inverse notation. So the inverse is equal to 1 plus x over x minus 2. All right, so we've done the first part of what they're asking us for. They ask us to find the inverse. We've done that. The next thing that I want to look at with you is we want to take these two functions. So we're going to take the original function as well as the inverse, and we want to talk about the domain and the range for both functions. Okay, so for the domain, that part should be fairly easy, at least in the sense that it is something that we have talked about before. Remember that when we have a fraction, we are looking at x values that would make the denominator equal to 0, and we're going to exclude those values. So if I look at my fraction and I look at the bottom part of the fraction, I know that if I put a 1 in for x, that's going to give me a 0 in the bottom. So I'm saying to myself that x cannot equal 1. Every other x value should be okay, but plugging a 1 in is going to create a 0 in the denominator, which is going to be a problem. So for my domain, I'm going to, and you can write it really any way that you choose. You can write it x is not equal to 1. You could write it using interval notation. So you could say we could go from negative infinity to 1 with a parenthesis, which remember means we wouldn't include the 1, and then pick right back up with the 1 and go to infinity. So that excludes the 1 but includes everything else. Or I'm okay if you just want to say all x values except x is equal to 1. So again, you can use the method here that you feel most comfortable with in terms of finding your domain. All right, so I'm going to come down to my inverse function, and I'm going to do the same thing. All right, so let's talk about the domain for this function. All right, so again, I'm looking at the denominator of my fraction, and I'm saying to myself that x cannot equal 2. Because if it equals 2, that's going to cause a 0 in the denominator, and that's going to be an undefined point on my graph. So again, write this in any way that you feel comfortable doing. We can say x cannot equal 2. We can build an interval notation around the 2. Or we can say, and this is the one I probably prefer, just say all x values except 2. All right, so that takes care of the domain. And again, I kind of feel like that is at least something that we've been taught, so that part shouldn't be entirely new for us in terms of coming up with domain. Now, range may be a little bit more difficult for you, so I want to show you kind of a nice trick that I can use to find the range for my functions. All right, so what I want you to remember is that when we started talking about finding the inverse, we said that in all cases, when we go from the function to its inverse, the x's and the y's switch. So remember that the domain is the set of x values and the range is the set of y values. And when we go from a function to its inverse, those sets are going to switch. So what I'm saying is that the domain on the original function will switch and become the range on the inverse function. Remember, x's and y's switch. So what that enables me to do is to write the range by simply copying what I wrote up here for the domain. Now, I'm not going to write it all down. I'm just going to write the last method, but again, you can use any method that you want. Now, I am going to change it to a y instead of an x. So I'm going to say all y values except y is equal to 1. All right, so just to be clear, I took this exact expression right here and I copied it down for the range. And the only thing that I did was I changed out, instead of saying x's, I said y's, because we are talking about y values when we talk about the range. Okay, now I'm going to do the same thing on the other one. Okay, so let me clean this up a little bit so we've got some room to work. All right, so what we're going to do is we're going to take the domain on the inverse function, and it's going to become the range on the original function. And again, I'm just going to copy. So I'm going to come to what I wrote for the domain right here, and I'm going to copy it down for the range. And the only thing I'm going to change is, instead of saying x's, I'm going to say y's. So all y values except y is equal to 2. And so what this does is it gives us kind of an easy way to find the range on a function when we don't really have that much experience finding the range. Like, we haven't really worked on that, but now that we know that the domain and the range switch places, it becomes a little bit easier for us to answer those questions.